So Apple today just released their new Apple Silicon Macs, and I think that this is going to be a big move for the industry. And you might be wondering, well, why is Mindtech talking about the new Macs? He's a PC guy. Well, guess what? I think that Apple's switching to ARM is going to be a huge shift and a huge exodus of the old and outdated x64 and x86 architecture. So in today's talking head video, I'm going to be talking about, first of all, what Apple Silicon is, and then I'm going to be sharing some of my predictions as to what it's going to mean for especially Intel, AMD, and Nvidia. So without any further ado, let's jump right in. If we go to the Apple website and look at Apple Silicon itself, they have a lot of marketing terms that you kind of have to ignore. But I think the first big thing that they talk about is the system on a chip. A system on a chip basically means that you have a lot of the critical computing components all combined into one. If we look at a traditional motherboard here, as you can see, you have your CPU as one chip, then you have your RAM on another bus that has a pretty fast connection between the CPU, but again, that's not instant because it is on a different bus. And then you have your PCI devices on a completely different bus. This is a lot slower than having a direct connection with the CPU. And then on top of that, you have different RAM speeds, you have different CPU speeds, different CPU manufacturers, and then you have different GPUs. So there's a lot of different variation, which I love personally. But if you look at something like the Raspberry Pi, the way that they're able to make this computer so small, and the way that they're able to get so much performance, albeit it's not like a performance powerhouse, but still, you can get a lot of stuff out of this Raspberry Pi. And then you might be thinking, well, that's just something that Raspberry Pi does. Look at this. This is an iPad. You don't have DRAM chips that you can add into your iPad. Same thing with an iPhone. Same thing with the Samsung phone. They all use system on a chips because it is incredibly efficient, and you can really get everything integrated together and tweaked to your liking. The first thing that I thought was really impressive was 5 nanometer. Of course, they've achieved stuff like that in their phones before, but on a desktop class CPU, that is incredible. Really, the best architecture design that we have so far is AMD's 7 nanometer. So the fact that Apple is already pushing for that 5 nanometer, I think, is honestly going to start to encourage some competition with laptop manufacturers trying to make it so that their processes are a lot more efficient. The second big thing is that shared memory and that shared GPU all on one chip. And this honestly kind of reminded me of like the AMD Radeon APUs that include both Radeon graphics and Ryzen processing cores. I think that that is honestly pretty good for laptops also. You're not going to have to worry about having a completely different graphics processing unit that then complicates the motherboard, makes the chip sizes bigger, increases costs. If y'all have that as one, you're going to have a really fast communication between that, your DRAM, which is going to be shared between both the graphics processing unit and the central processing unit, and that's honestly, I think, going to give for what Apple is describing as this very snappy experience. Plus, you have 8 CPU cores. It's okay compared to what you have right now. If you look at like the Mac Mini, their Intel offerings, which are considerably more expensive, which really surprised me, only have about a 6-core design, whereas these offer 8 cores. But then again, you have some trade-offs because Apple is doing 4 high efficiency cores and 4 high performance cores, which I honestly don't really like. I just don't know why they can't jam in 8 high power cores and just call it a day. And I think that's the other big thing with Apple Silicon. They have macOS Big Sur, which is 100% designed to take advantage of this architecture. So if you're a Mac person, this should be really exciting for you. Previously, they had to contend with what Intel was doing with their CPUs. They had to really design drivers, design hardware abstraction layers to work with somebody else's stuff, where now they can do that all in-house. I think that's why we see such high performance with the iPhones compared to Android phones, because if you have to deal with Snapdragon, you're not going to be able to fine-tune everything and fix microarchitecture bugs with the team next door. Now we have to talk about some of the stuff that kind of made me mad about their presentation. So they're comparing the latest laptop chip to Apple M1. I don't know what this chip is. I don't exactly know what benchmarks they're using, but I still think that it is interesting that they're able to push so much power per watt. And that's a big thing when you talk about laptops. When Apple added the Core i9 processors to their MacBook Pros, you do have a very powerful x86 processor, but it produces so much heat because it's so inefficient that you're basically gonna have to trade off between thermal throttling or more cooling, and that's something that Apple really hasn't compromised on. So by using a reduced instruction set, which is basically what ARM is, that allows you to get a lot more performance per watt. And you might be saying, well, Mindtech, it's gonna be slow, isn't it? And I do believe it's going to be slow. When you first have to factor in Rosetta, that transition, you're not going to have a lot of apps that are compatible. You're still going to have to wait on your developers to not only transition their apps over, but you're also going to have to wait for them to optimize. ARM is a completely different architecture from x86. Apple themselves have already admitted that it is going to take up to 2 years to be able to completely, I guess, transition their lineup over to the M1 chips. I've already talked about some of the benefits that ARM will give you, but still, it is a completely different instruction set, and it's a completely different way that code has to be compiled in. If I wrote some C++ code on my AMD box and compiled it to run on that computer, then I went and tried to run it on an iPad, that's obviously not going to work. First of all, because iPads have proprietary languages. But second of all, the microprocessor in this iPad isn't going to know how to understand that code. It's just going to be like a bunch of Chinese to me trying to read an English book. Yes, Rosetta will be able to have developers do this so-called one-click transition. And yes, things like built-in Apple apps like Big Sur, like the calendar app or the clock app or the App Store, those are obviously going to run very well because Apple's had time to fine-tune and possibly even rewrite all of these apps so that it will run well. But something like Adobe Photoshop or DaVinci Resolve, that isn't going to be able to run as well. Something like video editing also, those require a lot of CUDA cores and a lot of GPU optimization that you're not going to get on an Apple-built GPU. But a 3D application that runs really well on the iPad or has already been written for ARM, maybe something that would run very well on a Raspberry Pi, that's gonna run well. That game that you downloaded off of Steam that either runs on an AMD GPU, an Intel integrated GPU, or an NVIDIA GPU, you can't guarantee that that's going to run too well. And that's what kind of makes me a bit confused. Obviously, they're gonna have to release machines, but that certainly does not mean that these boxes are gonna run well. You see that Apple marketing, you see their graphs, and you think, oh, it's gonna be really fast. You have to keep in mind what applications you're using. Again, if you're using the built-in applications from Apple, you're probably going to have a faster experience. You will have better battery life because these chips are more efficient. But if you use any third-party applications, which I'm pretty sure most people do, honestly, wait. I know that developers have already had their transition kits for a while and they've had time to optimize, but it's still going to take longer for the mainstream to be able to optimize 100% of applications. But I still do believe that this is the future. And I believe that by Apple transitioning over to ARM chips, that will eat the industry. Let's face it, x86 is an outdated architecture. It was outdated in the 1990s when RISC came out. What a RISC does is it makes it so that instead of having to do 1 billion operations just to complete one task, you might only have to do 10. Once things are optimized, once you make it so that it runs well with fewer instructions, I think that there's really no way to beat RISC. Think about this. Remember when Intel transitioned from the Pentium 4 to the Core 2 Duo? They were moving from this really terrible single-core Pentium 4, which still was really fast at single-core operations, but it ran super hot, it was super unreliable. They really took a step back to something more like a Pentium 3, but then they doubled that, and then they made it more efficient. Once they took just a bit of a step back, they were able to do innovation that has led the last 15 years. So I think that the industry is really going to have to take this cue from Apple, and they're going to have to say, what are our laptops and our desktops going to look like in 15 years? Is it still going to look like a computer from 1982? Still going to look like a 386? Literally with the same architecture, just with a few modifications? Is that what we're going to be running in 20 years? No. That's an easy no. Once all these major companies start to learn how to optimize for the Mac, I think that's going to be huge. And I'm really excited to see, now that ARM is in the process of being acquired by Nvidia, now that Intel has been really lacking on their packet size and they haven't really been developing x86 even more, I'm really excited to see what these companies have up their sleeve. I really wonder what's inside of the AMD labs. I wonder what's inside of the Nvidia labs. Is this going to be an ARM chip in 10 years? Are we going to be building computers with ARM that only require 20 watts, that don't require any massive water cooling setups? Will I be able to have a gaming computer that's 100% silent, just like these new MacBooks and just like the Mac Mini? That's honestly really exciting for me, and I think if you're a big PC nerd, I think you should be very excited about this too. Now, I'd like to quickly go back to some of the other cons that we're going to have with the Macs. If you go to the configuration screen for the Mac Mini, the first thing that I noticed is that it is a system on a chip. So what the system on a chip means is that you're going to have these computers 100% locked down, which is, I think, a necessary step, but it's really a step in the wrong direction for right to repair. This is going to make it so that maybe you can't upgrade your storage in the future because the security, which Apple talked about a lot in their event, is going to be so tightly locked down to exactly what Apple wants. You're not going to be able to throw in a new processor. You're not going to be able to possibly upgrade your SSD. Obviously not upgrade your RAM. I don't really like that direction, honestly. Plus, saying that it is a system on a chip, it isn't like on an iPhone you're able to quickly replace components. With a computer like this Mac Mini, there aren't any big components that you can replace like you would be able to on an iPhone. I think that it's honestly going to be very difficult for people that want to customize their Macs, people that really want to add in new graphics cards, expand their experience. I don't know if that's really going to be Apple's future or even the industry's future. I did present maybe we will be installing ARM chips into our motherboards in 10 years. Maybe not. Maybe we'll be buying an entire motherboard, not being able to do anything else with it. And that's honestly the grim side of this. I hope that that isn't the case. I love being able to customize my builds and fix them when they break and upgrade them. Systems on a chip are very appealing, like I described in the beginning of this video, but it's not really appealing for right to repair. So with that said, guys, thank you all for watching. I hope you enjoyed what I had to say, and I hope you are both as excited and as skeptical as I am. Thank you all for watching. I hope you enjoyed, and I'll catch you all in the next video. Bye-bye.